So what I want you to do is go, you don't have to write any of this stuff right now. All I want you to do is go into your calculator and type in y equals 2x. So you just go y equals 2 to the exponent x, and then, yeah, 2 to the exponent x. And then zoom 6, because you're probably in some crazy trig window right now. You don't want any crazy trig. It's back to standard. No, really? You didn't zoom 6? Oh, that is just a sad day.
See, that's great. I'm always the first.
You didn't zoom 6?
Wait, what are we zooming?
Zoom 6 sets it back to negative 10,
No,
10, 10, 10.
-10, +10, go down.
It's just a sad day.
No,
You ever zoom 6'd it?
no.
Zoom 6 is a wonderful joy. It brings joy to hearts of children everywhere. Oh, how did you guys make it this long? Oh. So press graph. What happens? You get an exponential curve. What is it getting closer and closer to but not touching? The y-axis. Why is that? Because if you put the, it's the x-axis, not the y. If you put the -3 in, 2 to the -3 is actually 1/8. Correct? Because if you went 2 to the -3, that would be the same as 1 over 2 to the 3, which is 1/8, right? And if we went 2 to the -2, that would be 1/4. And if we went 2 to the -1, that's 1/2. If we went 2 to the 0, 1. 2 to the 1, 2. 2 to the 2, 4. 2 to the 3, 9. I can't go back and say I didn't say it because I said it and it's recorded. 8. Yep. 2 to the 4 is 16. Good times. All right. So we have -3 to the and the 1/8, -2 and the 1/4, -1, -1/2, 0 and 1, 1 and 2, 2 and 4, 3 and 8. And it's running like this. Now, whenever you graph a graph, you guys, on a test or anything like that, or even in your book, that was kind of shady and stuff, you should always say what your scale is. Because right now, I'm just like you're just assuming I know what your scale is, right? When you do this, what you should always say is x scale, in this case, is 1. Y scale is 1. That means every tick is worth 1. So now when I look at your graph, I actually know what the heck I'm looking at. If not, I'm looking at an exponential function. And this could be at 1,000,000 on the x and 5,000,000. Like, it could be crazy, right? Because the scale matters. So you have to tell me, if not, this graph could be anything positive for y. Okay. So what we have here is this is going to get closer and closer and closer to 0, but it's never going to touch 0 on the x-axis, right? Because your fractions are just going to get smaller and smaller and smaller and smaller, but they're never going to actually turn into 0. So what you have here is you actually have an asymptote. You have a horizontal asymptote at y equals 0. Because remember, the x-axis is y equals 0, the y-axis is x equals 0. They have equations, right? Because they might say reflected about the line y equals 0, and if they do that, that means reflected on the x-axis. Into your y2, put in 10 to the power of x. In your y2, put in 10 to the power of x. What happened? It's closer to the what? It's closer to the y-axis. Now, why would that happen? Because if I go 10 to the 0, it's still 1. So that would have stayed here, right? And then if I went 10 to the 1, instead of it being at 2, it's going to be at 10. So it's going to rise way quicker, right? Exponentially, it's growing faster. And remember, when you do that, that's why that's your base. So if it's a 2 in there, in that spot, then it's doubling. If it's a 3 in that spot, it's tripling. If it's 10 in that spot, I'm going to call it 10ing. The decading. Decading. doing something. It's growing really fast, okay? So did the graph itself, did the asymptote change? No. What's the only thing that's going to change that asymptote? Thinking of transformations. What's the only thing that can move that little x-axis dealio? Vertical translation. Would a vertical stretch change it? Can you stretch a line, like make it wider? No. Horizontally is not going to do diddly squat to it. Like it'll move the graph this way, or stretch it wider or narrower, do all these fancy things. And a reflection in the x-axis, what would happen? It would drop, but my asymptote would still stay there, right? So the reflection in the x-axis wouldn't change my asymptote. What about a reflection in the y? It would now be, instead of increasing, it would be decreasing, but my asymptote would still be there. So the only thing that changes this asymptote is a vertical translation. And I'm going to write that as a little caveat. Only some serious symbols here. A short form. The only thing that moves the horizontal asymptote is a vertical translation. Means the ha is the vut. It's my own language. What's the domain of this graph? XER just keeps going on forever, whether it's this way or this way, right? It's going to be XER. The only thing that makes it not be XER, you guys, an exponential function, is a word problem, just like everything else, right? If it was a word problem about time, you can't go negative time, right? So it would be x or t, in that case, is greater than or equal to 0, right? So exponential graphs, if it's just a plain old exponential graph, is XER, but if it turns into a word problem, that doesn't mean it's going to stay that way, right? It depends on what your x value is. The range in this case is y such that y is what? Not equal to, right? So my asymptote can change with a vertical translation. How can my range change? A whole bunch of things can change my range, but what can change my inequality sign? A reflection in the what? X-axis. So if you don't have a reflection in the x-axis, you're going to have that. But you will, your inequality sign will flip when you have a reflection in the x-axis. I'm going to write that as a little caveat too, down here. For range, y is greater than the number. What is this number always? Where do you get that number from? That number is the asymptote, correct? What is the asymptote reliant on? What did we just say? Vertical translation. Your vertical translation is the only thing that moves that asymptote, right? So your asymptote is basically at your vertical translation. If there is no vertical translation, your asymptote is at 0 because there's no vertical translation of 0. If your vertical translation is up 7, then your asymptote's at 7. And this is your asymptote, right? This is your horizontal asymptote. So basically, it's your vertical translation. So that's where that number comes from. Your asymptote is just your vertical translation. Oh, my day just keeps getting better and better. I have on pajamas. I'm going to finish that because if I didn't, that would be crazy as to what they would leave them guessing. And I got slippers from my lockup. And now. So for these ones, I told you the b value was 3 or 2 or 10. Exponential functions are always a b to the x. That is the form they're in. In this case, there is no a, but a can't be 0 because it would be 0 times 3 to the x. And what's 0 times 3 to the x? 0. That doesn't, and there'd be no function. It would be just y equals 0. It would be the x-axis. It would be your asymptote. That would not be good. Okay? So if there is no a, what does it have to be? 1. So this one's a 1, this one's a 1, this one's a 1. The A didn't change. My value for B in this case is 3, 4, 5.25. What's happening as these are getting higher? It's just steeper. It's growing faster, right? Exponentially growing faster. What's the y-intercepts of these ones? When you fill in, when you're finding y-intercepts, you fill x equals 0, correct? So if I fill a 0 into here, 3 to the 0 is, 4 to the 0 is, 5.25 to the 0 is. So these all actually, that was so exciting, guys. Come on. Come on. 0 to the 1, 0 to the 1, 0 to the 1. Can't wreck my day, guys. I have on pajamas, slippers, and I just got eggs. Just can't. Kick me and I would still be happy, okay? Don't try it, but I would still be happy. All right. Okay, what happens if I change my A values? So this one has an A value of 1, 3, 4, 5.25. So in Y1, type in 2 to the x. If you don't have 2 to the x in it, type in 2 to the x. In Y2, you have to type in 3 times 2 to the x. Now, this does matter how you type it in. So you're going to type it in as y equals 3, and then in brackets 2 to the x. Why do you have to do that? Because if you don't, it's going to go 3 times 2 to the x, which is actually 6 to the x. Is that true? Is that the same thing? No, this x is only to the 2, not to the 3. Okay? So type it into your y2. What happens? It's not steeper at all. Well, kind of. It is a tiny bit steeper. Yes, it goes up sooner. It's not translated. It's a what? It's a vertical stretch. Yes. So it's vertically stretched by a factor of 3. So every y value is being multiplied by 3. So it is going up faster. You were correct. It is going up faster. Okay? My b value for all of these is 2. Now, what's the y-intercept of these ones? Well, the 0 only affect, or the 0 in the exponent only affects the 2, right? So this would be 2 to the 0, which is 1. This one is going to be 2 to the 0, which is 1. And 1 times 3, which is 3. And then 4, 5.25. Everyone really likes this because translations or transformations are so like in your head now. It's like, oh, of course, that's what that is. But when I start teaching transformations, there's a lot of sad faces. But now happy faces. And there's warm air coming from somewhere? Oh. I didn't think that they could get better, but we have heat, guys. We have heat. Okay. What happens, though, if instead of a 2, I put in a third? Punch that into your calculator. What happens when you put the third in? When you go 1/3 to the x? It decreases, right? Does the asymptote change, though? No, and of course it doesn't, because there's no vertical translation. Of course. Of course it doesn't. It would have to have, like, y equals 1/3 x to the plus 7, let's say. Then what would be my asymptote? 7. It'd be at y equals 7, because it moved 7 up, right? And my range would be y is greater than 7. Why wouldn't it be y is less than 7? I would need a negative a value in order for it to reflect in the x-axis, right? So my range would change to less than if I had a negative a value, but I just do not. Okay? So my domain is XER. My range is y is greater than 0. Oops, forgot the y such that. It's greater than 0 because I'm doing it for the actual first function, not the crazy one. I put a plus 7 at the back. I'm doing it for this one. My asymptote is at y equals 0. Do I have any x-intercepts? No. Now, some people will say you can never have x-intercepts because the asymptote is on the x-axis. Never is a little bit strong. In these instances, you can't have any x-intercepts because the asymptote is on the x-axis. But if I move my asymptote off the x-axis, I could possibly have x-intercepts, correct? Now, this one here where I did the 1/3 x to the 1/3 to the x plus 7, I'm not going to have any asymptotes because the entire graph is above 7, right? If the entire graph is above y equals 7, there's going to be no asymptotes. How could I change it, though, to instantly get asymptotes? X-intercepts, what did I say? Oh, I lied. How could I could replay that, but I'm not going to. What could I do to the equation this? Y equals 1/3 x plus 7 to get x-intercepts. Nope. Yes, you could make it be -7. That's true. That's not my brain was going, but that's true. If you made it be -7, it would be below and then it would cut through. Or you could have a negative a value and it would cause it to reflect down from +7 and it would cross through somewhere. Okay? So, describe the transformations. You can only compare, remember how we did like x squared and then I gave you transformations on the x squared, or I gave you x cubed and gave you transformations on the x cubed? You can only compare values of exponential functions if they have the same base. The base b has to be the same because it doesn't cause any stretches or transformations or anything. So the value in front here, a, gives you your vertical stretch and your reflection in the x-axis. Your value b gives you your horizontal stretch and your reflection in the y-axis. Your h gives you your horizontal translation and your k gives you your vertical translation. So technically your x is in the exponent now, right? So if it's just a plain old x in the exponent, you have no horizontal stretches, you have no reflections in the y, you have no horizontal translation. But you also have to remember that same thing that I told you that they're going to do throughout the whole test, and I will do throughout my test, is you have to remember to take that b value out. If you have like bx minus, or if you have like 3x minus 6, you have to take the 3 out and make it be x minus 2 to get the proper horizontal translation, right? That doesn't change in any unit. Transformations the whole way through, that horizontal stretch has to come out, or the reflection has to come out, and then it'd be bracket x plus or x minus something in order to get your horizontal translations correct, right? Okay. So you guys tell me what happened here. I have 4 to the x, and now I have 4 to the x minus 2. I can compare them because the bases are the same. What does this 2 do? Vertical stretch by a factor of 2 about the and then what does this x minus 2 do? 2. Right. It looks a lot worse than it is, B. What I would do if it were me is this negative is not to the 2. Do you remember in grade like 9 where they would give you like -3 squared and then you tell them that's -9? Or they'd go bracket -3 squared and you tell them that's +9, right? Because unless the negative is in the bracket to the exponent, you assume it's not with that number. Remember that? They did that like a whole bunch of times in grade 9. It's back. So this negative here is not with the 2, is it? No. You also can't have a negative base, so that's good because the question wouldn't work. But this one here doesn't have one either. So it would be y equals, if I want to write this out properly, I could go -1, 2 to the x, 1 over 5x, because I can bring that out, right? I can make it be 1 over 5x instead of x over 5, and then people get it right. And then you'd have -4 at the back. So what do I have? Do I have any vertical stretches? No. Do I have any horizontal stretches? Yes. I have a horizontal stretch by a factor of 5, because we always flip it, about the What else do I have? Reflection in what? Do I have anything else? Now you're going to answer a whole bunch of questions for me. Yay, I know. Domain? XER, because it's only XER. It's not XER if it's a word problem, right? It could still be, but it might not. Most of the time it isn't. What's my range? Y such that y is less than -4. The reason why is my asymptote moved from 0 to -4, and my graph flipped in the x-axis, so it's less than. Can I have any x-intercepts? No, because it's at -4 and down. See, not hard. Okay. This one is a little bit of a trick, but you guys, I want to see if you get it. Go. Do example 2. Remember that you have to have the same base in order to give me transformations. So this one's 1/3 x, and this one's y equals 3 to the x, and I want transformations. So y equals 1/3 x, and y equals 3 to the x. And remember, you can only give me transformations if the two equations start with the same base, which is the value to the, Brielle just got it, because her little eyes just lit up. And I just said her name. Frielle just got it. Yep, Frielle. Brielle? Wiel. Ziel. It really just sounds terrible unless it's actually correct. Yeah. TL. Ooh, I like that one. We're going to call you TL for today. Yes.
1/3 is 3 to the negative.
Yes, 1/3 is 3 to the -1. So this would be 3 to the -x, and this would be 3 to the x. Or you could change this one. You could have said this is 1/3 to the -x, but no one ever goes that route. But you could, yeah? So all it is a reflection in the y-axis, you guys, which makes sense. Y equals 3 to the x is an exponential growth function. Y equals 1/3 x is an exponential decay function, like this. So they're going like this. What are they reflecting on? I feel like an air traffic controller who does a really bad job. Or Mr. Kennedy. Okay. Okay. Does that make sense? All right.